Hello, in this lesson, we're gonna work on ArcCoTangent. Before we work on ArcCoTangent, let's recap what we have done for cotangent. We know that cotangent is a function, right? It is a rule that assigns each input angle in the domain exactly one output in the range, right? And we figure out the domain and range for ArcCoTangent already, right? And we already have the graph, right? So we're still working all of these on the stage set of 3 pillars of trigonometry. All the angles are measured from standard position. A positive angle is being measured counterclockwise. A negative angle is measured clockwise. Reference angle is the positive acute angle between the terminal and the x-axis. Definition. Here we're coping with the cotangent definition, right? For cotangent that it's x over y, right? So the physical presence of x is the horizontal measurement and the vertical presence of the y, which is the blue. So red divided by blue. Red divided by blue will give us the cotangent ratio. And of course, we work out the graph, right? And we figure out that the domain it can be any real number, but, okay, cotangent, the domain can be any real number, but multiples of pi. So let me type that word for you. Any real number, but, or except, okay, except multiples of pi. Okay, so that's the domain for cotangent in words. And of course, you can also say any real number, okay, in shorter term. You can also say any real number, but k pi. Okay, and k represent any integer. Range, all real numbers. So we got the range, right? We got the domain, and now we want to create a new function. That new function is going to take the all the values from the range, all the ratios, and produce for each ratio produces exactly one angle. Okay, to produce exactly one angle, right? All the possible ratios are from negative infinity to positive infinity. But this time we cannot allow to have more than one output because that would not be a function. So for that purpose, right, we're going to look at all the possible ratios, and we realize some of those ratios can be achieved by more than one angle. For example, root 2 over 2, root 2 over 2, right? Red divided by blue. Okay, that ratio is 1. And so for ratio 1, hold on, let me just clean up this a little bit, right? I'm being squeezed. There's not enough space. Wait. Okay. All right, hopefully this is better, right? For example, for the ratio, right? For the ratio 1, right? For ratio equals to 1. Okay, for ratio equals to 1. What, right? Ratio, the ratio I'm talking about is x over y, right? The red divided by blue. Red divided by blue. Say the red divided by the blue, right? For the example equals to 1, for that ratio equals to 1. How many angles, if this ratio is the input and we produce, and we send this to ArcCoTangent, say, ArcCoTangent. Okay, we take this ratio 1, and we're gonna produce one angle. We can only produce one angle, right? But then we look at this unit circle, we notice, well, wait a minute, right? You can see if I measure counterclockwise, and I get to √2/2, and that ratio is 1, and that angle is pi/4, right? So I got a pi/4. Great, I got a pi/4. Wonderful. Pi/4. Oh, not 5. Okay, pi/4. But if I keep going, I found that if I keep looking, I can find another red over blue ratio also equals to 1, which is negative √2/2. This ratio is also equals to 1. Okay, and I found another number, and that is a 5 pi/4. 5 pi/4. Okay, and what is more, I can get more because I can measure the angle on this terminal. I can measure the angle clockwise, right? So for that reason, I can get a negative, right? This angle, if I measure clockwise, I will get a negative 3 pi/4. 3 pi/4. And I can go around and round. I have many angles that corresponds to that terminal that produces the ratio equals to 1. But this kind of phenomena cannot be allowed by function definition, because this rule produces how many output? More than 1. So this way, it cannot be allowed. No. We cannot have this kind of rule, because this way, ArcCoTangent cannot be a function. It is not a function, okay? So we have to make sure we get exactly 1 output. And among all of these possible output, which one is the simplest? Which one is the simplest? Apparently, the simplest is pi/4. The simplest is pi/4. Okay, and then we decided, you know what? We're gonna keep quadrant 1, because quadrant 1 give us ratios that are positive, and the angles are, the output are simplest. And we're going to cross out all these others. So these are out. And if you have any more, they're all out. They're all out. Okay, so ArcCoTangent as a function has to guarantee the output is exactly 1. It cannot be less than 1. Okay, less than 1, you have no output. That means it cannot be, and that number cannot be the input, right? And so with this understanding, we decided, no, we can only have exactly 1 output. So these are out. These are out. These are out. That means that I'm going to cross out a quadrant. This quadrant is out. This quadrant is out. Why? Because whatever ratio we have for cotangent, and these will give the same ratio, and then that will cause multiple, more than 1 output. So we have to rule out the entire quadrant. In other words, if we measure the angle, we cannot even fly over. Remember, we measure the angle, we actually fly over, right? We actually fly over here. No, we cannot even fly over it. We cannot even fly over it. Okay, so now quadrant 3 is out. Quadrant 4 and quadrant 2. Quadrant 4 and quadrant 2 for the same reason, right? Look at this example. Look at this example. If I have a ratio input equals to -1, right? -1, and I gave it to ArcCoTangent, right? What will happen? And I found that if I start from this way, and this will give me the red to blue ratio, it's a -1. So I get 3π/4, okay? But if I go clockwise measurement, I get a red over a blue negative √2/2. I got another -1. So this way I will get at least 2 answers. And which one is more desirable? That's the question. Which one is simpler, right? Because I will also get -π/4. Okay, -π/4. Right? I have 2 answers. Of course, we cannot allow 2 answers for ArcCoTangent. ArcCoTangent said, no, if you allow -π/4 and 3π/4, if you allow 2 output to exist, and then ArcCoTangent is not a function. So we have to guarantee it's a function. And the mathematical community decided, you know what? We are going to get rid of -π/4. And now this quadrant is out as well. And also -π/4 is out. Okay, if that makes sense. So now, if you look at the red to blue ratio, every red to blue ratio is going to be unique. And its angle, okay, the output will also be unique if we limit ourselves only to quadrant 1 and quadrant 2 and no flight zone. So we're never going to cross. This is no flight zone. No flight zone. Okay, no flight zone means you cannot fly over. You cannot fly over in any way. Okay, you cannot fly over in any way. Okay, so that's how ArcCoTangent is created. Okay, ArcCoTangent is created by dropping quadrant 3 and quadrant 4, and look at the ratio we can form by red divided by blue. Okay, red divided by blue, and that correspondence with the angles measured from standard position again, right? Only counterclockwise, no clockwise measurement. No clockwise measurement. So you cannot go that way. No, you can only go counterclockwise. And let's see, what do we get? What do we get? Okay, we know it cannot be 0, right? 0 cannot be in the domain. 0 cannot be in the domain. So we're going to look at the correspondence with the curve we got. Okay, once we do this, right? Let's look at the what has happened to the curve, right? What happened to the curve? What happened to the curve is, right? Since we crossed out the quadrant 3 and quadrant 4, and this is the no flight zone. No flight zone. Right? So when we measure our angles, right, from the standard position, okay, counterclockwise, from a little bit larger than 0, not including 0, from 0, we can only get to pi, not over pi. So from 0 to pi. So the angle we get, the arc length we get, right? The arc length we get, which is to have the horizontal measurement, can only be between 0 to pi. And where is 0 to pi in the curve we did last time? Well, it's, so this piece of arc length, okay, this piece of arc length, whoops, hold on, okay, this piece of arc length is the maximum, okay, is the maximum we can get. Okay, this piece of arc length, this piece of arc length. Okay, and what would that be on the graph? It's from 0 to pi. Okay, so as a result, all of these chopped off, cut off, chopped, and all of these are chopped. And whatever is left, only this slice, right? From 0 to pi, not including 0 to 0, not including pi, is a piece that passes horizontal line test. It passes horizontal line test, and it has inverse. It has inverse, and that inverse is called ArcCoTangent. Okay, ArcCoTangent. So let's look at this function point by point for whatever we can do, right? For the special terminal, for the special point, of course, we see better. But how about for the non-special ones? The goal to study special is to apply the whatever we get to non-special, right? So that's what we're gonna do. All right. So let's look at a point by point. Okay, point by point. There. Okay, point by point. Okay, so this function has inverse. So this function, we can give it a name if you want, but we don't have to. We just say cotangent on the interval 0 to pi exclusive. Okay, exclusive. Exclusive meaning does not include 0, does not include pi. Okay, so this function now is 1 to 1. Okay, and we're going to define our ArcCoTangent. We're going to define our ArcCoTangent. Okay, so let's do it. So what is a cotangent in 0 to pi? So let's look at those values. Okay, and of course we're talking about those special values, right? We're going to talk about those special values. I'm going to make a bunch of rows. Okay, enough for us. Okay, so angle A, cotangent of A, where A is in that interval, right? And you know, ordered pair, input output, right? Input output. Okay. Now, starting from zero. Okay. We know we cannot take 0, but we can get close to 0, can we? So we can get as close to 0 as possible. So when A is approaching 0, from larger than 0, we know that, right? Cotangent of angle is going to approach positive infinity. We saw that, and that's what happened, right? When the angle approaches 0 from larger than 0, and the output is getting higher and higher yet. So that's what we saw in the last lesson, right? So we see this again. And the other point is pi, right? Pi. So these are a little too thick, right? So let me make it just a little thinner. All right, so when x is approaching pi, when the angle approaches pi from smaller than pi, right? You can see this is pi. Now we're approaching from smaller than pi, and that output, the ratio are approaching negative infinity. So we have these, right? And then we're gonna record it. We're gonna record it. Okay. So clear them all, and we're gonna record that what we just said, right? When angle approaching zero from larger than zero, cotangent ratio approaches positive infinity. When the angle approaches pi from smaller than pi, and cotangent of the angle approaches negative infinity. Okay, so there are a lot of points, there are a lot of special points in between, so we can work it out. Okay, so in order to work this out, so I'm going to bring that unit circle with us. Okay, we can bring that unit circle with us. And so we just put it next to us. We'll put it here, right? We put it right here. Okay, and under the circumstances, we are just working with quadrant 3 and quadrant 4 chopped off. Okay, this is the no-fly zone, okay? So with that said and done, we can start from left to right or right to left. It doesn't really matter, right? So suppose we do it from right to left because the right side is easier, right? So 0 in the neighborhood of 0 is being taken care of. So the next one, right? ARD, right? We measure from the standard position and we get to pi over 6. So all that narrative that we've done many, many times now is applying to cotangent. So terminal is pi over 6, and we pick any point on the terminal other than the origin. Because we can pick any point on the terminal other than the origin, and we pick the point on the unit circle, and that will give us the same ratio. And this time we know the coordinates of that ratio, which is red, √3/2. The other one is half. To get a cotangent ratio, we will need to take the red number divided by the blue number. So cotangent of pi over 6 is going to be the red √3/2. I hope you guys still remember. Okay, so let's do it. Let's just do it this time in case you forgot. Right, so let me put this over here. I got some minor technical issues here. Oh, come on. Come on. This piece. This software is very good in many ways because it gives that mathematical, you know, what you type is what you see. But it does sometimes it's kind of just messed up. Okay, I put them in certain place, it moved away. There. All right, so you guys go ahead to do the calculation, and I will be right with you. Wait, not this one. Okay, I just want to move those grid over here. I don't know if you guys can see this. All right, I think I have. I hope I didn't miss anything. But anyway, cotangent pi over 6, right? So we said we're going to do that calculation. We're going to do that calculation. So right here. Okay, so I'm going to take the red number divided by the blue, right? You guys probably have done it. Okay, so √3/2 and divided by half. Okay, and you reduce it, you get √3. Okay, so angle is the input. Okay, and ratio is the output. Okay, on the other side, right? On the other side, when we create ArcCoTangent, and what we're going to do is that we're going to take the ratio, okay, because this time we're dealing with a cotangent, ArcCoTangent that takes ratio, it produces angle. Okay, produces angle, and ratio can be any real number. Okay, so I'm just going to, right now I need this, I need the space, right? So for pi/6, that's the input, output is √3, input, output, I'm going to swap. Remember that way when we are finding the inverse, right? We swap. So the swap the input and output. That's what ArcCoTangent does. So ArcCoTangent √3, it takes a ratio as input. It produces the output, which is going to be an angle. Oh, gee, I did lose something. I think I did lose something. I lose that pi/6. Okay. All right, but hopefully that's not a terribly a big deal, because I can copy and paste. Let me hold on just 1 second. Okay. Symbol cache, math, symbol panels. I think I just put it away somehow. I don't know where I put it. So awkward. I'm so used to what I see is what I type is what I see. Okay, and this one. Okay, so hold on. Okay, I'm going to resolve this to see if this is possible. Okay, just 1 second. You guys continue your calculation, okay? All of these, mass object, mass symbol cache, compute, mass template, symbol panel. Huh. Orange button. No, show 2 tips. All right, no big deal. I can still work it out. Okay, let's see if I'm in the share. Okay, I'm in the share. Okay, so we continue this process and then we get the points for ArcCoTangent, which is √3 is the input. Okay. √3 is the input. And the output is the angle. You can see that swap all takes place. Okay, that swap takes place. That's the making of the cotangent function. For each input, exactly one output. Each input, exactly output. So the function definition is satisfied. Okay, so function definition is satisfied. So we continue to work on this, right? Continue to work on this for pi over 4. Okay, so I'm going to just do this. Pi over 4, pi over 3, right? And pi over 2. So you guys just work with me. And also 2 pi over 3, right? 2 pi over 3. And keep going. I'm going to insert a bunch of rows. Okay. And along the way, we have 3 pi over 4. Okay, 3 pi over 4. 3 pi over 4. And 5 pi over 6. And then we get close to pi. We know we cannot have pi, right? So these are the special terminals. These are the special terminals. For each one of them, we're going to go through this process. Okay, so let's do it. Be patient with ourselves, and we can do it, right? You can see the process. Okay, so cotangent pi over 4. Okay, pi over 4. And we already did that. That was 1, right? That was 1. And so the input is pi over 4. Pi over 4. And the output is 1. And on the other side, 1 is the input. Arc cotangent 1 is going to give us pi over 4. There you go, right? And we do this point by point to really experience, right? Really experience what's happening for input ratio, and the output is pi over 4. There, okay? So let's do this one by one, every one of you, okay, who's watching, right? Cotangent of, so I'm going to remove this, right? This way I have more space, right? I have more space. So cotangent pi over 3. And the ratio is √3 over 3. √3 over 3. And now we have the point, input, output, input, output. Okay, the output is √3, sorry, √3 over 3. Okay, on the other side, it's √3 over 3. Okay, and arc cotangent takes that ratio, √3 over 3, and it produces an angle. That angle is pi over 3, pi over 3. Okay, so that angle is pi over 3. You can see that's how arc cotangent is produced. Okay, arc cotangent is produced. And once we create this function, we created that program. That program can handle any ratio and will produce an angle between 0 to pi. Okay, so for this guy, it's √3 over 3, right? And the output is pi over 3, pi over 3. Okay, pi over 2, cotangent pi over 2, right? Equals to 0. How do I know? Well, you just have to look at the right here. You measure the angle, right? Whenever you kind of got carried away, well, you just do ARD. You measure the angle pi over 2 right here. And on the terminal, there's a point there waiting for us, right? So red divided by blue, so that's a 0, right? That's a 0. So just focus on ARD. So on this point, right, it's pi over 2 input, and the output is 0. On the other side, I have a 0, arc cotangent of the 0 equals to pi over 2. Pi over 2. So the point is a swap of input output from its inverse function, right? From its inverse function. So now 0 is the input and pi over 2 is the output. Pi over 2 is the output. Okay, keep going. Cotangent 2 pi over 3, right? 2 pi over 3. So 2 pi over 3. And that output, right? We take the red number divided by the blue number right here, right? And we're going to get negative root 3 over 3. Negative root 3 over 3. And now we got another point, right? 2 pi over 3 is the input, right? 2 pi over 3 is the input. The output is negative root 3 over 3. And we do that same thing all over again. So when the input is a ratio, arc cotangent root negative of root 3 over 3. This is a negative. Sorry, I forgot the negative sign, right? So root 3, negative root 3 over 3. I need to remember no one is watching me, actually. I'm just pretending, right? So that's going to be 2 pi over 3. 2 pi over 3. 2 pi over 3. I think we're getting a little bit crowded. So what I'm going to do is that I'm going to, oh, I actually lost a lot of stuff. Hold on. Okay. That's okay. We can manage. Okay. Not a problem. Not a problem. Okay, we will make it. So this point, okay, after the swap, right? After the swap. So the input is negative root 3 over 3. Okay, and the output is 2 pi over 3. You can see the input is negative, but the output is positive. 2 pi over, I'm sorry, 2 pi over 3. I have to. 2 pi over 3. Let's see, did I make any mistake? I know no one is watching, okay? I'm by myself, there's no help. There's no help, okay? All right, we keep going, right? You can see the swap. You can see the swap, right? So I need 2 more rows. Actually, I need 3 more rows, right? 1, 2, 3. Here we go, right? So these correspondence. And next, 3 pi over 4. 3 pi over 4. Cotangent 3 pi over 4. 3 pi over 4. 3 pi over 4. And that is equals to -1, right? -1. Because negative 3 pi over 4, I'm sorry, cotangent 3 pi over 4. Okay, just be reminded. I want to remind you, right? Also reminding myself, that's 3 pi over 4. Cotangent 3 pi over 4. On the terminal, there's a red number, there's a blue number, red divided by blue. But before the red number, there's a negative root 2 over 2. Okay, so with that, okay, this is going to be equals to -1. Okay, so the point on the curve, which we did last lecture, is that we have the input 3 pi over 4, and the output is -1, and then we swap the input output. Look at that. We're doing this consistently. Okay, math is nothing but consistency. Okay, if we lose the consistency, no one is going to trust math anymore. Okay, and that's how consistent we are. So for input ratio, which is -1, the output is 3 pi over 4. Right? You can see all the output are positive. All the output are positive, right? Because the range of ArcCoTangent, this range is from 0 to pi, 0 to pi, right? So that range. Anyway, keep going. Okay. 5 pi over 6. Cotangent 5 pi over 6. 5 pi over 6 equals to, right? It's right here. This is the terminal. This is the terminal. Remember, right? We measure from the standard position. We terminate over here. And that's the 5 pi over 6. On the terminal, we take that red number, divide by the blue number, and we're going to get a -√3. Okay, we're going to get -√3. -√3, where? Okay, so this is going to be -√3. Okay, the point input output, which is 5 pi over 6, right? 5 pi over 6, comma, -√3. Input, output in that order, consistently. Okay, and now -√3. -√3 is the input for ArcCoTangent. So ArcCoTangent of -√3. See, that's 1 to 1. That is 1 to 1. So this is going to be 5 pi over 6. Okay, and the point we're getting is, okay, so I'm going to 5 pi over 6, excuse me, and the ratio is -√3. -√3. Excuse me. Okay, and that's our ArcCoTangent. Last but not least, one more, I put one extra row which is not needed, is that for near 0 and near pi, right? Near zero, we're from larger than 0. So if we swap these two, what will happen? Well, when the ratio, right? This is the ratio approaching infinity. So when this ratio approaches infinity, right? When ratio approaches positive infinity, and what do we get here? The angle approaches 0. Okay, so ArcCoTangent, it just swap these two. We swap these two. Okay, so ArcCoTangent of that ratio is going to approach 0 from larger than 0. You can see the swap, right? These two swapped. And now, and then I'm going to show you later on the picture. And for the pi, right? For the pi, when angle approaches pi from smaller than pi, cotangent ratio approaches -infinity. So now my ratio approaches negative infinity, when x is approaching negative infinity, our angle, okay, arc cotangent angle, right? Arc cotangent give us an angle, right? The output is angle. That angle is going to approach pi, okay? Pi, I need a pi from smaller than pi. You guys need this in calculus, for calculus classes. Okay, yes, you do. Ooh, we are done, right? Not too many points, but these points are representative enough to tell us something about the non-special ones. The non-special ones, right? For the special ones, we know them, right? For non-special ones, it's going to be the same, right? Any ratio, right? Any ratio you give me, any ratio is given to us, right? The output will be positive between 0 to pi, okay? That's what it meant that the output is going to be larger than 0, smaller than pi. Okay, no matter what ratio you give me, the output is going to be between 0 to pi. In other words, whenever you see arc cotangent of anything, right, it can be any real number as a ratio, the output is always positive. The output is always positive. Where we see here clearly, that means the angles for the output of arc cotangent, the angles are always measured counterclockwise. And how is that reflected on the picture? How is that reflected on the picture? Well, this is the arc cotangent. This is the cotangent on the left, right? This is the cotangent on the left. And on the right is a cotangent, is an arc cotangent, right? So this piece, okay, this is a cotangent. Doesn't give me the mode. Okay, no problem. Okay, I know where to get it. Cotangent, right? So this is a cotangent of A, right? Where A is inside the interval of 0 to pi. 0 to pi. Okay, I know I can find pi. Pi is somewhere here, okay? And this other one is arc cotangent. Okay, this is the curve of arc cotangent. Okay, and this curve, okay, this curve is between 0 to pi. So this green line is y equals to pi. Okay, and this bottom one is x-axis. So the curve is between what? Between 0 to pi. This curve is decreasing. So these two, if we put them together, we're going to see they're perfectly symmetrical with respect to y equals to x. Because this software I'm using doesn't give me the graph for arc cotangent, so I'm going to use decimals. Okay, I'm going to use decimals to show you this. Okay, so make sure you have the notes with you, and let's go to decimals. Okay, let's go to decimals. New share, right? This is decimals. See, these are the points we have done, right? These are the points we have done. So here you can see y equals 0. That's the horizontal asymptote for arc arc-cotangent y equals to pi, which is the green one, root 3 pi over 6, right? So that's a purple point, which is this one. So I'm going to click on the label. You're going to see it right there. The next one, 1 pi over 4, I click on the label. Look at the picture right there. The red is root 3 over 3, and the output is pi over 3, and right there. Okay, and keep going, 0 pi right here, right? Negative root 3, comma 2 pi over 3, we did that point for arc-cotangent right here. And keep going, negative 1, 3 pi over 4, negative 1, 3 pi over 4. So that purple dot, right, purple dot, they're all color coordinated. They're all color coordinated, okay? So this program is pretty useful, at least for me. So the last one, okay? And as now, look at the endpoints. Look at the endpoints, right? There's no end. Why? Because it's to infinity, right? But we want to have a peak to infinity. Change the color. I'm going to change to the gold color, right? I'm going to change to the gold color. So as the input ratio goes to infinity, I should not use the orange, actually. I should be using ratio color, whatever. As the ratio goes to positive infinity, okay, arc-cotangent approaches 0 but larger than 0, okay? As the ratio approaches negative infinity, arc-cotangent is approaching pi from smaller than pi, okay? And we saw that right here. We saw that right here, okay? So let's go back to that screen, what I just said. Okay, so the new share over here, right? These are the two ends. These are the two ends. On this direction, right? This corner tells us, right? As x approaching infinity, arc-cotangent approaching 0 from larger than 0, That's this corner. Okay, so, and the other one, okay, as the ratio approaches negative infinity in this direction, arc-cotangent approaching pi from smaller than pi. You can see the entire curve is less than pi, but above 0. Okay, so this is arc-cotangent as we have done it. Okay. I think that's all for this lesson. Thank you for watching. If you have any questions, please don't hesitate to reach out to me. And thank you for watching.